Okay, now when you watched the last video, we had already selected what shapes were similar using ratios, type of shape, and angles. So in this lesson, we're just going to be looking at how do you find the scale factor between those similar shapes. So when we had figure A here, we saw that the ratios with this figure was 2 to 3, and that the ratio from figure B was 4 to 6, and that 4 to 6 reduced to 2 to 3, and that they had equivalent ratios. We saw that in figure C, 2 to 6 reduced to 1/3, which was not equivalent, and so we know that figure C is not similar. So we're only going to focus on looking at figure A and figure B. Now, scale factor, I will be using just SF instead of writing out the word scale factor. It's called a scale factor because scaling is when you make something bigger or smaller, or equally bigger or smaller, and factor is what we call a number in a multiplication problem. And so scale factor is the number we multiply, and I'm not going to write out the whole thing, but it's the number that we multiply by all sides in order to enlarge or reduce a figure. So when figures are similar, they have to have the same scale factor, or the same number multiplied by all their sides. In order to determine the scale factor, we have to look at corresponding sides, which again means sides in the same location. So when I look at figure A, I'm going to be looking at the short side. The corresponding side in figure B is the short side in figure B. The long side in figure A, which is 3, is corresponding to the long side in figure B, which is 6. Now this shape has been rotated. So maybe we can rotate it back and that will help. So here's figure B rotated to be in the same position. And that makes it a little bit easier to see the corresponding side, short side to short side, and long side to long side. Now we need to determine what number was multiplied by the sides in order to get the scale factor. So if I'm looking at 2 and I'm looking at 4, to figure out what number it was multiplied by, I could take 4 and divide it, so 4 from this side, and divide it by 2 from the corresponding side. Once I divide the two corresponding sides, I get the number 2, and that tells me that this side was multiplied by a scale factor of 2 in order to get the new corresponding side. I could have done the same thing with 6, the long side, divided by the other long side, divided by 3, and again I would have got 2, because the scale factor of 2 was applied to the long side in figure A to get the long side in figure B. Now, I also have to find the scale factor going from the larger figure to the smaller figure. The only difference is instead of taking my longer side, 4, and dividing it by 2, I'm going to take my shorter side, 2, and divide it by my corresponding short side of 4. 2 divided by 4, the division symbol is the same as the fraction symbol, so 2 divided by 4 is the same as 2 divided by 4, written like that, which is 2/4, which is equivalent to 1/2. So the other scale factor is times 1/2. We could have done the same thing over here when it was 2, that 4 divided by 2, just put a little arrow here, is the same as 4 divided by 2 written like this. 4 over 2, of course, is the same as 2 over 1 or 2. And we would double check our answer by going 6. Last time we did 6 divided by 3, so this time we're going to go 3 divided by 6, which is the same as 3 divided by 6, written like this, which is equal to 1/2. So, just to recap, I'm going to clear all of this out. We had figure A and we had figure B. The scale factor from A to B was 2. The scale factor from B to A was 1/2. 2 is the same as 2 over 1. Remember that when we found these, I'm just going to look at the short sides, which was just one of the possibilities. To get the scale factor of 2, I took 4 and divided it by 2. That was the same as 4 divided by 2, which is the same as 2 over 1, which is the same as 2. When I found this scale factor, I just divided in the opposite order. So instead I did 2 divided by 4. So again, the exact same thing as the scale factor from small to big is big to small, dividing in the other order. That's the same as 2 divided by 4 written like this, which is the same as 1/2. Okay, when I look at my scale factors for my blue figures, my right triangles, I'm looking at corresponding sides again. So I'm going to look at the longest side in this figure and the longest side in this figure. I can see that 3 was multiplied by 4, which means our scale factor is 4. I would of course double check that by saying, is 2 times 4 8? Yes. 2 times 4 again is 8, so our scale factor is 4. I could have actually gotten that number by taking this 12, dividing it by the corresponding side of 3, knowing that 12 divided by 3 is the same as 12 divided by 3 written like this, which is the same as 4 over 1, or the same as 4. Now remember, to find the other scale factor, going big to small, we simply do division in the opposite direction. So instead of doing 12 divided by 3, we're going to go 3 divided by 12. 3 divided by 12 is the same as 3 over 12. This simplifies to 1/4, and therefore has a scale factor of 1/4. The other thing that you need to think about is the only number that we can multiply by a figure without changing its size is times 1. So if it has a scale factor of 1, it will be the same size. If it has a scale factor that is greater than 1, it will get bigger. If it has a scale factor that is less than 1, it will get smaller. So I could go back and look at the scale factors I just got and see that when the scale factor was 4, that was obviously our small shape to our big shape because the scale factor is greater than 1, meaning it's going to make it larger. When I look at this scale factor, I can see that 1/4 is less than 1, therefore I knew it would make our shape smaller. When we look at our scalene triangles, again I think I'll pick the long side to look at first, and its corresponding side in figure G, and see that to get from 4 to 12, I had to multiply it by 3, meaning my scale factor was 3. I could have gotten that scale factor again by taking 12, dividing it by its corresponding side 4. 12 divided by 4 is the same as 12 divided by 4 written as a fraction. I know that this is correct for small to big because it is a fraction that has a value greater than 1, and it is the same as 12 divided by 4 is the same as, divided by 4 would be 3 over 1, which is the same as 3. If I do my scale factor going the other way, from the big triangle to the smaller triangle, again I would take my sides and I would say 12 and 4, but instead of taking 12 and divide it by 4, I'm going to take 4, divide it by 12, say that is the same as 4 divided by 12 written as a fraction, which reduces to 1/3. 4 divided by 4 is 1, 12 divided by 4 is 3, so I have a scale factor of 1/3. I know that that is the big to the small because it is also a fractional value less than 1. Now remember, you always want to double check that the same scale factor has been multiplied by all sides. So when I look here at 2, if I took 2 and multiplied it by our scale factor of 3, I would get 6. So I'm comparing the short side to the short side, and then I'm going to look at my middle length side and say if I had the side of 3, which is the middle length side, and 9, which is the middle length side, and I use my scale factor of 3. 3 times 3 is indeed 9, so I know the scale factor worked for all sides. Lastly, if I look at my two equilateral triangles, and I guess I could have rotated the last one, but we'll rotate this one so that they're this easier to see in the same position. And I go to find my scale factors. Again, I want to look at corresponding sides. The thing about the equilateral triangle is because they're all the same size, it doesn't really matter which one you look at. So I'll just pick this side here and this side here and say, well, what was multiplied by 2 to get 3? Now the number got bigger, so I know it has to be a scale factor of greater than 1. And I know that I can divide to find it. So I can do 3 divided by 2 to find it because I'm looking at this side and its corresponding side. I know that's the same as 3 divided by 2 written like this. Sorry about that. I know it has to be a value of greater than 1 because my figure is getting bigger. And then 3 divided by 2 is the same as 1 and 1/2. So my scale factor is a scale factor of 1 and 1/2. Now to go the other direction, meaning for starting with my big figure, going to my smaller figure, I know it has to be a scale factor of less than 1. So instead of taking 3 and dividing it by 2, I take 2 that I got from here, and the 3, which I got from its corresponding side. It's 2 divided by 3, which is the same as 2 divided by 3 written as a fraction, and it cannot be reduced at all. So my scale factor is 2/3 going the other direction. Now, many of the students have noticed a pattern with the scale factors that helps make this process a little bit faster. So if we look at this, we go back to the rectangles, and I see that one of my scale factors could be written as 2/1, and my other scale factor was 1/2. Go to my next slide, I can see that one of my scale factors was 4/1 or 4, and my other scale factor was 1/4. If I looked at my one scale factor was 3/1 or 3, and my other one was 1/3. And I had a scale factor of 1 and 1/2, which could be written as 3/2, and the other one is 2/3. What students notice then is that when my scale factor was 2, it could be written as 2/1. That the scale factor, this is making it bigger, so this was going from the small figure to the big figure because it's greater than 1. That the big to small scale factor, the bigger figure to the smaller scale factor, bigger figure to a smaller figure, would be 1/2. That when the scale factor was 3, which could be written as 3/1, that the scale factor from the big figure to the small figure was 1/3. When the scale factor was 1 and 1/2, which could also be written as 3/2, that the scale factor was 2/3, is that many of the students noticed that when we get this scale factor, that the two scale factors have the same digits in them, they are just flipped, or that they are reciprocals of each other. And so some students just find the small to big one and then flip it or get the reciprocal of it to get the other scale factor.